Welcome back, guys. So in this video I'm pleased to announce a new series I'm going to make. Since I see a lot of people online, they actually complain that they complain that not many people cover the entire syllabus. So that's what I plan to do in this series. Okay, we're starting from, let's say, chapter 1, right, going up to, I think it says it chapter 28 or 29, right, over the whole AS and A2. So yeah, I mean, it's going to cover everything. Now, of course, this series is good. Well, one, if you're self-studying, right? Okay, if you're not going to school. I guess other people that I don't know, maybe they were sick, right? Maybe they're on holiday. Yeah, they missed an entire chapter. Right, or of course, people that just want a review, of specific chapters. Now, in order to keep in order to keep the video shorter or sort of more manageable for some people, then as well as the kind of full content long videos, then I'm also going to make probably 30-minute to 1 hour videos at the end of each chapter. Just kind of recapping all of the content in that chapter. Let's just jump in then to this first video. Now, I will actually say that, the first video we're just going to look at the course overview, right? So the syllabus, the different exam structures, right? Things like that. Now, if you're familiar with this already, honestly, just skip, right? Go to the next video. If you're just starting the course, right, or if you're considering doing this course in future as a sort of prospective student, then maybe this video is going to be useful. Right, so I guess the whole thing, right, AS and A2 is going to be split into 4 units. Right, that's going to be over 2 years. So in effect, 2 units per year, right, 2 in AS and 2 in A2. Right, each year there's going to be 1 theory exam and 1 programming exam. I guess units, right, and therefore 1 exam for each unit. Right, 2 exams per year, right, hence 4 units overall, right, therefore 4 exams over the 2 years. Right, each exam is out of 75 marks, and basically each exam is kind of weighted equally. So since there's 4 exams, therefore each exam is therefore worth 25% of your final A-level grade. If you're just talking about AS, then of course, since AS is only 1 year, right, then each exam is worth let's say each of the exams in the first year, right, is worth 50% of your AS. Of course, over the 4 years, each exam is worth 25%. And then, right, in terms of the knowledge, I would say the knowledge is actually quite wide-ranging, especially compared to some of the other courses. For example, AP, right, which focuses mostly on programming. I know they do also have a theory part as well. But maybe I'm a little bit biased, but for me, this is quite a good course. And it's going to cover a lot of chapters, which we'll see in a minute. And this is good for whether you want to study CS, right, computer science or electrical engineering, or even if you don't. Because speaking to people, for example, someone did business, someone did physics, I know other people that are doing maths, they're also using programming, right, in these subjects at university. Computer science is kind of, useful regardless of whether you're doing CS or not. Right, now, if we look at the course content, and there's kind of a huge amount, so I'm probably not going to go over everything, right, just to sort of read through it quickly. Unit 1, or effectively exam 1, and then, here I've broken it down into chapters. So chapter 1, information representation. We're going to cover different number systems, so binary, hexadecimal, right? Binary base 2, hexadecimal base 16. Right, something called BCD, right, binary coded decimal. Right, images, sound, video, text. Different, let's say, different character sets, right, Unicode and ASCII. Right, different ways we can encode data, right, different forms of compression, right, lossy and lossless. Right, then JavaScript, PHP. So this was in the old syllabus. Now, probably, I think what I might do is, probably I won't make a video at the start, but maybe once I've covered the whole syllabus, right, I might just make videos, about this, right, if anyone is curious. Right, then chapter 2, communication networking. So we're going to look at LANs, right, local area networks, right, WANs, wide area networks, different network topologies, so effectively kind of different structures of networks, like the star, the bus, the mesh, right, hybrid networks, point-to-point. Right, then we'll look at client-server model, I guess cloud, basically just servers, kind of remote computers. Right, of course, we'll look at Wi-Fi, right, we'll look at the Ethernet protocol, fiber optics. Right, streaming, so both real-time and on-demand streaming. We'll look at the World Wide Web, right, also the internet, and right, the difference between these two, because they're actually not the same, right, despite what many people many people use these terms interchangeably, right, but there is actually a difference between the World Wide Web and the internet. Right, then we'll look at various protocols, so for example, IP, DNS, right, the MAC, so DNS, the domain name server, which, what that's going to do is going to convert from okay, right, so it's going to convert a domain name into an IP address. And just to say an IP address, well, this is going to be an address that uniquely identifies a device on a network. And this could be a private IP address, so just a kind of identifying a device, say within a LAN, right? Or it can be a public IP address, which is going to uniquely identify the device in the entire world. Right, then there's going to be NAT, so network address translation, and that's going to be about converting a private IP to a public IP, right, and vice versa. So yeah, public IP to private as well. Right, then 3 is going to be hardware, so we'll look at I/O devices, right, input-output devices. For example, mouse, keyboard, speakers, touchscreen, of course, many different devices. Right, then we'll look at primary storage, so that's going to be RAM and ROM. Right, then we'll look at secondary storage, so hard drives, SSDs, optical storage like CDs, DVDs, Blu-rays, magnetic storage, so for example, magnetic tape. Right, then embedded systems, so just small systems designed for a specific purpose. Random access memory, read-only memory, as mentioned. Right, then 4 is going to be logic gates and logic circuits, and I think actually a lot of people find these, find this chapter easier, since this is more kind of mathematical. Whereas I guess, these two especially, there's a lot of writing, right? There's a lot of descriptions. Just as you can see by the amount of content here. So 4, right, it's going to be, just kind of drawing logic circuits, right? Making something called a truth table, where here we have, some inputs, right? Then we just have to calculate what the output would be. Then just, some logic expression. Using things like and, or, not, XOR, right, etc. Right then, chapter 5 we'll look at processors, so something called the von Neumann architecture, and this was developed, I think, I want to say maybe in the 50s, right, the 1950s, maybe the 40s, maybe the 50s, this is still used today, right, so it's kind of stood the test of time. Right then we'll look at registers, so that's going to be fast access memory inside the CPU. The cache, again, this is also fast access memory, not as fast as registers. Although again, right, this cache, this is also, some of it is inside the CPU or inside the core. Some of it will be shared between multiple cores. So the difference between level 1, level 2, level 3 cache. Right, then there's going to be the ALU, the arithmetic logic unit, and this is responsible for doing all of the all the arithmetic and logic calculations. And of course, when we say arithmetic, that means I guess kind of mathematical, right? So addition, subtraction, multiplication, division. And when we say logic, we're just kind of talking about, I guess really the logic gates. Logic gates, and, or, not, XOR, or etc. Right, something called the IAS, right, the immediate access store, so just, memory. Really, I think this is more commonly referred to as cache, right, also RAM. Right, buses, so just way of transferring data, from the CPU and between other components. And we'll see there's 3 types, right? There's going to be the address bus, the data bus, and the control bus. Right, then we'll look at, the performance of the CPU and how we can improve this. For example, by adding more cores, increasing the amount of cache, and increasing the clock rate, or the clock speed. Right, then we'll look at how instructions are executed using the, fetch decode execute cycle. And right, we'll look at interrupts. So if something, if a process is executing, but then maybe the user does something like, and then maybe say clicks the mouse, or types on the keyboard, or if I don't know, maybe there's some hardware error, right? Then this thing is going to have higher priority. Okay, therefore this needs to execute, and the current process needs to be paused, right, temporarily. Right, then chapter 6, it's going to be assembly language. Now assembly, maybe people are not familiar with, but this is going to be sort of a low-level language. And when we say low-level, it's kind of close to the CPU. So this can actually be quite difficult for some people in terms of, probably because it's not human readable, or it's not as human readable as, for example, some of the higher level languages. All right, then, machine code, that's just binary. Right, then something called an assembler. So an assembler is going to take your assembly code and then convert it into the machine code. Right, then we'll also look at addressing. So addressing, I think there's 5 types. Let me see if I can remember. So there's going to be immediate addressing, right? There's direct, indirect, relative, and indexed addressing. So you should be familiar with all of those. Right, then 7, and I think right here, this is the last one for Unit 1, right, just this page. Right, monitoring control systems, so sensors, for example, infrared, let's say, sound sensors, right, heat sensors, sort of oxygen sensors, I guess many different types. Right, so again, kind of logic circuits, right, and also bit manipulation. So while using assembly instructions to, for example, get specific bits, right, set specific bits. Right, then 8, well, it's going to be system software, so we're going to look at operating systems. Right, we're going to look at program libraries, so this can be, well, static and dynamic libraries. Again, we're going to look at assemblers, right, so converting from assembly into machine code. Right, compilers, well, so this will be from a high-level language. For example, yeah, I mean, I guess if we look at the ones on A level, well, that's going to be what, Java and Visual Basic. Right, so going from a high-level language to machine code. Now, technically, Java is not sort of fully compiled, right? It's kind of both, right, compiled and interpreted. And then, right, if we look at an interpreter, well, that's just going to execute I guess it's going to execute kind of each statement by statement, right? It's not going to convert the entire code into machine code first. Right, then we'll look at IDEs, so integrated development environments, and these are just the programs that allow you to write the code. Or I suppose, okay, let's say, right, they're going to be programs that allow you to more easily write code because they're going to provide additional features. All right, for example, well, code completion, syntax highlighting, probably a built-in debugger, right, where you can add breakpoints, right, do single stepping, yeah, look at the report window. Yeah, I think various things like that, right? I think context-sensitive prompts, that's another one. Basically just code suggestions. I mean, that's really what that means. Right then, 9, well, security, privacy, integrity. So, right, that's going to be different threats, for example, different types of malware. Yeah, for example, well, spyware, viruses, worms, trojans. Yeah, right, different types. Right, so security measures, or how we can prevent this, well, strong password, biometrics, firewall, antivirus. Yeah, sort of, well, let's say user permissions. Right, validation, so how we can check the data seems to be in a kind of reasonable format. Yeah, that's kind of what they say for validation. Right, verification, well, this is not only checking that, well, of course, I mean, first it has to be validated, right, make sure it's a reasonable format. Then verification, well, this is checking that the data is actually correct. All right, then access control, well, I suppose, yeah, different permissions. Of course, not all users should have, complete, yeah, I guess, complete access over the whole system. Right, then 10, well, ethics and ownership, so, right, different ethical principles, yeah, for example, well, talking about things like copyright. Right, talking about different licensing, so, for example, well, yeah, I guess, well, open source, yeah, shareware, freeware, right, commercial licensing. Right, then also talking about some moral arguments about AI, right, or artificial intelligence. Right, then finally, so, and again, right, this is just unit 1, right, this is all the theory. So then there's going to be databases, and we're going to look at, well, okay, kind of storing data in a, well, okay, yeah, I guess storing data in a kind of text-based system, or using, well, let's say a database, yeah, a kind of database approach. Right, then we're going to look at SQL, right, so this is an actual language used to perform queries, right, so structured query language. And this will allow us to, well, create, let's say, create the database, right, create the table, yeah, insert data, update data, select data, right, delete data, yeah, etc. Right, we'll look at, well, relational databases. So, I mean, basically just what SQL, right, or yeah, kind of MySQL. Right, we'll look at something called ER, right, so entity relationship diagrams. Right, normalization, so how we can efficiently store the data, yeah, how we can efficiently store the data in the database without having repeated data. Right, then we'll look at the DBMS, so the database management system, and, well, really that's just going to be MySQL. I mean, of course, there are, well, yeah, okay, there are actually many different types of SQL, but MySQL, I mean, basically it's the free one. It's kind of the most commonly used one for just kind of, yeah, individuals, right, for beginners. Yeah, again, because it's free. All right, then, well, DDL, so data definition language, kind of creating tables. Right, then, well, DML, so, well, data manipulation language. So that's going to be, well, selecting, right, updating, deleting, yeah, actually kind of modifying that data. Right, then if we go to unit 2, so this is the programming, and I think here, right, we only have one slide, so yeah, kind of not as much in some ways. Right, chapter 12, well, that's going to be algorithm design and problem solving. And well, here we're going to look at something called abstraction. So abstraction, this is basically about kind of removing the unnecessary details, or yeah, removing the kind of overly complex details, just focusing on the kind of fundamentals of the problem. Right, decomposition, so this is taking, let's say, taking a big complex problem and breaking it down into, let's say, smaller, more manageable steps. Right, then we'll look at modules, so this is going to be kind of, okay, creating a reusable block of code that we can then call, in many different places throughout the program. So rather than just having to, copy and paste the same code over and over again. yeah, we can actually create, yeah, I guess we can create what's called a function or procedure. Now, a function will be a module that basically has an answer, okay, or returns a value. Whereas a procedure, well, this is going to be a module that, well, I mean, basically it's not going to return a value. Now, it can do other things. For example, it can output data to the screen, right? It can write to files, it can read to files, but it's not actually going to return an answer that we can use in another part of the program. And of course, I mean, well, when we look at that, I'll speak about that in more detail, since, yeah, I think this is a distinction that a lot of people kind of find hard to understand. Right, well, then we'll look at input. So, yeah, inputting data. Now, of course, well, that can be, yeah, the user typing in data into a program. It can also be, for example, like reading data from a file. Right, so process, well, that can be, yeah, some sort of calculation. Right, output, well, again, I mean, that can be outputting to the screen, right, or outputting to a file. Yeah, writing to a file. Right, assignment, so this is taking data and then, well, kind of, let's say, putting it inside a variable, basically. And well, sequence, again, that's some sort of calculation, right? Selection, so this would be what if statements or case statements. So executing certain code based on certain conditions. Repetition, so well, I'm just repeating code, yeah, sort of in a loop basically, or yeah, sort of iteration. Right, then we'll look at something called pseudocode. So pseudocode, well, I mean, this is just going to be like a fake programming language. But yeah, this is what they use in AS, right, and also a little bit of A2. But well, yeah, I guess like if people have done IG already, okay, I mean they should be familiar with pseudocode. All right, then we'll look at flowcharts, right, the different symbols. I mean, structured English, they haven't really asked that this much, or they haven't asked it sort of recently that much. I mean, basically you can think of this just like bullet points. Yeah, just kind of writing the code, but in just sort of bullet points, just explaining to someone else, yeah, how it would work. Right, then stepwise refinement, and I mean this is kind of similar to decomposition, where we just take a big problem and then we say, well, step 1, step 2, step 3, yeah, maybe step 3.1, right, 3.2. So yeah, just breaking it down into the individual steps. Right, then we'll look at the different data types and data structures. So well, integers, right, whole numbers. Right, then we'll look at reals or floats. That's going to be a decimal number. Right, we'll look at a char, right, so a character. So a character, well, just let's say a single character like A, for example. Yeah, it could also be, I know, the exclamation mark, where it could be a number like 5. Right, then a string, well, this will just be 0 or more characters. So, for example, a hello is going to be a string. Right, then we'll look at arrays. So an array, I mean, this is going to be a way to store multiple values. So rather than, for example, just a string where, we just have one string, well, we could have, let's say, an array of names, where we could have, let's say, all of the names for all of the students in that class. And actually, I do realise, right, there is also one extra, right, so there's also going to be dates. So yeah, we can look at how to store dates. And I think, yeah, for some reason, I've also not included Boolean here. So Boolean, well, this is just going to be true or false. Yeah, so I mean, I'll update this, right, yeah, once I made this video. Right, okay, then we're going to look at files again, reading and writing files. Right, we'll look at something called records. So rather than storing data in individual variables, we can actually have related data and store it as part of one record. So let's say we have a person. Now, maybe a person, right, they have a name, they have an age, they have an email address. Yeah, maybe they have let's say, an array of hobbies, right, or yeah, I don't know, maybe like an array of subjects they study. So what we can do with a record, well, we can store all of that data, as part of one object. And yeah, just access it as part of that one object. Right, then we'll look at bubble sort. So this is a way, well, just how to sort things in either ascending or descending. Now, ascending, what that means, smallest to biggest. So let's say 1, 2, 3, 4, 5. Right, descending, well, biggest to smallest. So yeah, I guess sort of, yeah, 5, 4, 3, 2, 1. Right, then linear search. So well, just kind of finding an element in a list. Yeah, seeing if it exists, seeing if it doesn't exist. Maybe counting how many times it exists. Right, or even finding the position that it first exists. Right, then we'll look at some abstract data types. So when we say abstract data types, I mean, basically this means, well, something that's kind of not built into the language. Or yeah, something that doesn't just contain, simple data. So in particular, well, that's going to be a queue. So a queue is going to be something called a first in, first out data structure, right, or FIFO. So this means, well, the data that kind of goes in first, right, when we then, okay, so yeah, when we in-queue data, right, goes in first. When we then dequeue that data, well, the first element to be dequeued will be, right, the first element that we put in. So, hang on, okay, sorry, that should be 1, right, if we have, well, yeah, 1, 2, 3 like this, then when we dequeue, well, I mean, of course, right, 1 is going to be dequeued first, right, then 2, then 3. Right, stack is going to be the opposite. So let's say, well, we push 1, then we push 2, then we push 3. Now, when we pop them, right, or remove them, right, in that case, right, 3 is going to be popped first, right, then 2, then 1. So stack, well, that's going to be called a LIFO, right, so a last in, first out data structure. Right, and then also something called a linked list. So this can be used, let's say, for example, in web browsers, right, to kind of remember which pages you visited in which order, where you have, let's say, page 1, right, then, well, this points to page 2, that points to page 3. So yeah, I guess kind of just like an ordered list, right? Right then, what assignment we've said again, so that's just kind of, I guess, what putting a value in a variable. Well, yeah, variables, of course, well, just something that can store data. Again, right, selection, yeah, if statements, right, iteration, well, I mean, selection is also case statements as well. Right, iteration, well, just three types of loops. So there's going to be a count controlled loop, and in particular, well, that's going to be a for loop in pseudocode. Right, there's going to be, well, a post conditional loop. So a post conditional loop, well, this means, right, you do the code, then you check the condition. So, well, that's going to be a repeat until loop, right, in pseudocode. Right, then preconditional, well, this means we check the condition, then we run the code. So, well, this will be a while loop in pseudocode. Right, then something called, well, pass by reference and pass by value. So, I mean, well, pass by value is the default. Now, this means that if we have a, well, module, right, function procedure, right, when we pass data into that as a parameter, then basically if we're using pass by value, well, that data will be copied. And anything that we change inside that module, well, that's not going to change the original variable. Because I mean, basically, right, what we've got is we've got a copy of the data. So we say, well, the copy gets changed, but the original doesn't get changed. Whereas if we're saying pass by reference, well, this is going to pass a memory address to that object, or to that variable. Right, therefore, if we update that inside the module, right, then I guess the original is going to get updated, right, since there's only one object. And well, right, then we'll also look at return. So this is just, well, returning from functions. Right, then finally, so yeah, because I mean there is also some sort of theory to this unit as well. Right, so well, the software development lifecycle, and that's going to have 5 stages. So the way I remember it is ADCTM. Right, so analysis, design, coding, testing, and maintenance. Right, then there's going to be the different, let's say the different development models. Right, so the waterfall model, the iterative model, right, rapid application development models. Right, there's going to be something called structure charts. So just showing how we can pass parameters, parameters and return values, right, between modules. So yeah, like between functions and procedures. Right, there's going to be something called finite state machines, and this is, I mean, basically it's going to say that, well, if we're in one state, then what input do we have to give, right, to go to another state? So let's say you have an ATM, right? Maybe one state is kind of I don't know, sort of like pre-login, right? So the I guess the user, typing in their PIN code, and then let's say the next state would be I don't know, let's say, right, login success. So of course in this case, well, I mean the input they have to give, is going to be the correct input. So if they give the correct input, well, then they're going to change from kind of the pre-login state to, well, of course, the post-login state. Right, then, well, yeah, I guess logic, okay, no, I say, well, 3 types of errors, right? Logic errors, runtime errors, syntax errors. So logic, I mean, this is going to be an error that doesn't crash the program, but it just kind of results in unexpected behavior. So let's say, for example, if you have, I don't know, maybe a greater than sign instead of a less than sign, right, or maybe something even more subtle. Maybe you do a greater than sign, but you should have done a greater than or equal to. So of course, yeah, these can be quite subtle, right, quite difficult to spot sometimes. Right, then there's going to be a runtime error. So this is going to be something that crashes the program after you run it. So let's say, for example, you have an array and the array has, I don't know, 5 elements. But if we try to access something at the 6th element, well, in this case, I mean, like since we only have 5 elements, right, then trying to access the 6th element, well, that's just going to crash because it's going to say, well, yes, the 6th element doesn't exist. And then the syntax errors, I mean, this is going to be caught before they run. I guess, yeah, if it's compiled, or if it's a compiled program, then this will be caught before the program is run. Because, well, this will be a problem with the actual grammar that they've typed. So, yeah, I don't know, like, yeah, maybe like missing some operator, or missing some kind of punctuation symbol. Right, then we'll look at the different types of maintenance. So there's going to be corrective. Corrective, this is about, kind of fixing bugs, right? Fixing things that are broken. Right, then there's going to be adaptive. So adaptive, this is going to be about, kind of changing existing features. So maybe someone says, we want this feature to do this instead. Or yeah, we want you to add this new feature. Right, then perfective. So here, I guess you say the program is already working, but we just want to either improve the performance, basically, right, just improve the performance, or maybe, I don't know, like improve the organization quality of the code, right, improve the readability of the code, something like that. And when I say performance, that can be both in terms of time, right, so making it faster, but also in terms of memory, right, so making it use less memory. All right, then, different testing methods, and to be honest, I can't remember all of those. There's like 8 of them. So yeah, like off the top of my head, definitely can't remember those. All right, then test data. There's going to be 3. There's going to be abnormal. So this is kind of invalid test data. Right, then there's going to be normal. Right, so that's valid test data. Right, then I guess we've got so there's kind of 2 more. Right, then we've got extreme. So extreme is going to be what the sort of highest acceptable, right, and lowest acceptable. And then we've got boundary, which is kind of a combination. So that's going to be a combination where you have 2 values, both the extreme, which is the highest or lowest acceptable, and then we're also going to go for let's say kind of like the variable that's like just too big, or the variable that's just too small. Just the variables, or just the values on the boundary basically. All right, guys. So I think that's everything. Now that's been a super quick recap. And to be honest, like even as a revision video, that might actually be useful since I've kind of covered everything there in, I don't know, maybe 20-30 minutes. But of course, hopefully this video is useful. And for people that just want to see the main content, of course, right, that's going to be in the next video. So as always, if anyone has any questions, just ask in the comments, and see you in the next video.